Last class, I taught what is integral test. One more I emphasize that the definition of integral test and where we use the integral test. Which type of infinite series for testing the convergence in this test. AIB sequence of positive terms and AI can be written as some f of I that fb function continuous decreasing positive function then f of x from 1 to infinity integral value is convergent and corresponding series is convergent and integral value is divergent corresponding series is divergent. So AIB positive and AI can be written as some function of f. This f will be positive decreasing continuous function. Then we can use this integral test. Here I will explain one problem. Show that P series summation n equal to 1 to infinity n power p converges if p greater than 1 and diverges if p less than or equal to 1. So you can write down the series summation in p equal to n equal to 1 to infinity 1 by n power p. That can be written as 1 by 1 power p plus 1 by 2 power p plus 1 by 3 power p plus etc. 1 by n power p plus etc. So an can be written as or ai can be written as 1 by I power p. So ai equal to f of I can be written as 1 by I power p. Without loss of generality, we can take this I equal to x. So f of x can be written as 1 by x power p. Is it okay? Yes. Then you can use integral test. This is a 1 by x power p. This will be decreasing. This is positive continuous function. So you can take integral test. Integral 1 to infinity f of x dx equal to integral 1 to infinity 1 by x power p dx. That is equal to, this is a improper integral. What is improper integral? All of you know improper integral is one of the limit is infinity. That is a one type of improper integral. So we can take b, limit b tends to infinity, integral 1 to b 1 by x power p dx. So this will become proper integral, so you can integrate. It can be written as limit b tends to infinity x power minus p plus 1 by minus p plus 1 1 to b. That can be written as limit b tends to infinity b power 1 minus p minus 1 by 1 minus p. So this integral will become limit b tends to infinity b power 1 minus p minus 1 by 1 minus p. 1 minus p is a constant. So we can take the outside of the limit value. So we can write 1 minus p, 1 by 1 minus p, limit b tends to infinity b power 1 minus p by minus 1. This limit value also can be written as 1 by 1 minus p, limit b tends to infinity 1 by b power p minus 1 minus 1. If p greater than 1 implies p minus 1 greater than 0. This implies b power p minus 1 is tends to infinity. It is 2 power 3, 2 power 4. That means p minus 1 is greater than 0. Some number, power positive power is always great, tends to infinity. As b tends to infinity. Okay. So we can write limit b tends to infinity 1 by b power p minus 1 will become 0. Since b power p minus 1 tends to infinity as b power infinity. Okay. So we can write the limit b tends to infinity 1 by 1 minus p is outside, b power p minus 1 minus 1. This limit will be 0. So we can write into minus 1. That is equal to 1 by p minus 1. This is finite value. So we can conclude here p greater than 1 summation 1 by n power p equal to 1 by p minus 1. That is finite. So corresponding integral value is convergent. Okay. So I will explain. In the case of p greater than 0, in the case of p greater than 1, integral 1 to infinity 1 by x power p dx can be 1 by p minus 1. This integral value is finite, so this integral is convergent. Therefore, corresponding infinite series 1 by n power p equal to 1 to infinity is convergent. Moreover, if p greater than 1, summation 1 by n power p is convergent. Okay. Next, if p less than 1, our integral 1 to infinity 1 by n power p dx equal to limit b tends to infinity b power 1 minus p minus 1 by 1 minus p. So 1 by 1 minus p is take outside. Limit b tends to infinity b power 1 minus p minus 1. So p less than 1, 1 minus p greater than 0. Okay. P less than 1, we can say 1 minus p is greater than 0. So here we got 1 by 1 minus p and b power of some positive value. 1 minus p is greater than 0. Minus 1 as b tends to infinity minus 1. So this value is infinity. So this integral is infinity. So this integral is infinity. So integral is divergent. So corresponding infinite series is divergent. I emphasize that if p less than 1, corresponding series summation 1 by n power p is divergent. Next we need to check p equal to 1. So we have the integral f of x dx equal to integral 1 to infinity 1 by x power p dx equal to 1 by 1 minus p limit b tends to infinity, b power 1 minus b minus 1. No. Sorry. Some mistake is here. In the case of p equal to 1, we can write the f of x is 1 by n. So we know f of x equal to 1 by n power p, x power p. So in the case of p equal to 1, f of x equal to 1 by x. Okay? Is it okay? So we can integrate 1 by x dx, that is equal to log x, from 1 to infinity, that is log infinity minus log 1. 1 equal to 0, log infinity. Log infinity is infinity. So in the case of p equal to 1, integral value is infinity. So we can say p equal to 1, corresponding series is divergent. So we can conclude in this way, in this series, in this p series, summation 1 by np is convergent if p greater than 1. Divergent p less than 1, and here lastly we integrate p equal to 1, that also divergent. So we got divergent if p less than or equal to 1. So we can conclude the p series is convergent if p greater than 1 and divergent p less than or equal to 1. Okay, this is the important